Hello, my name's Sophia and today I'm going to be teaching you about ions and ionic bonding. So some learning objectives for this lesson are to recap on electron shells and to know and understand the electron shell rules, to understand how ions are formed and to be able to deduce the charges of the ions from the periodic table, to know how ions form ionic bonds, and then to understand that ionic bonds result in the formation of an ionic compound. So a little recap on electron shells. If we look at sodium as an example on the periodic table, there's an 11 denoted above the sodium, and the 11 represents the proton number, and the proton number is the number of protons in the nucleus of the atom, and protons are positively charged particles. And so in order for an atom to be neutral, it must have the same amount of positively charged particles as negatively charged particles, and negatively charged particles are electrons, so they must have equal numbers of protons to electrons, which is down here. And also shells are organised in a 2-8-8-8 configuration going outwards from the nucleus, and lowest shells are filled first to reduce the amount of energy in the atom so it's more stable. So for sodium, if there's 11 protons, there's then 11 electrons. So on this diagram over here we've got sodium, and then around this we've got 2 electrons, and then we've got 8 in the next shell, and then we've got 1 in the final shell to total 11 electrons, and this is written in the configuration here as 2, 8, 1. So that's just a quick electron shell recap. Then if we move on to ions, so an ion is an atom or a molecule with a net charge due to the loss or gain of electrons. So it means there's now a net charge and there will be more either positive or negative particles in the atom. So atoms lose or gain the electrons. It's really important that the proton number never changes. It's always the electrons that are either lost or gained, and this is done in order to become as stable as possible, and so the atom has a full outer shell of electrons and then becomes an ion. So lithium on the periodic table here has 3 protons, so 3 electrons, and that's in a 2 and then 1 on the outer shell. So in order for it to have a full outer shell, it's easier for this lithium to lose 1 electron and then have a full outer shell of these 2 than it is to gain 7 electrons. So here, if we go over, lithium has 2 electrons and then it's in these brackets, and because it's lost 1 electron, it means it has more protons than it does electrons now, so that's why it's a positively charged ion. And positively charged ions are called cations here. So cations are positively charged. And then conversely, if we look at anions are negatively charged. So fluorine, which is in group 7, has 7 outer shell electrons, and that's seen in this diagram here, and it's easier for fluorine to gain 1 electron and make a full outer 8 shell of electrons instead of losing 7 electrons and having 2. So the fluorine then goes across like this, and if you see there's 8 outer shell electrons here, and one of them's teal, and that teal coloured one is the gained one. So now it means that the fluorine has more electrons than protons, and so is more negative in charge, so there's a negative here, and so anions are negatively charged. So, as I said before, groups 1 and 2 on the periodic table will want to lose electrons because it's easier for them to lose 1 or 2 electrons and have a full outer shell than it is for them to gain. So group 1 and 2 elements are metals, and they lose electrons and then they form positive ions, which are known as cations. And then on the other hand, 6 and 7, they want to gain electrons because it's easier for them to gain 1 or 2 electrons than it is for them to lose 6 or 7. So groups 6 and 7 elements are non-metals and they gain electrons to form negative ions. And groups 1 and 2 and 6 and 7 are most likely to form ions because they've got either 1 or 2 electrons out from a full outer shell. So I've just put in a table here which are handy ions to know. This is really good just to know and to be able to understand, especially in an exam situation, just to know them off the top of your head. It saves lots of time and it's just really beneficial, I think. So cations. Cations are positively charged ions, and they are formed by groups 1 and 2 because it's easier for them to lose electrons and therefore they become positive. So group 1, this is group 1 on the periodic table. They have 1 outer shell electron, so they lose that one and then they become positively charged. So that's lithium 1+, sodium 1+, and potassium 1+. And then group 2 have 2 outer shell electrons, so they lose them, become a 2+ charge. So that's beryllium 2+, magnesium 2+, and calcium 2+. And then on the other side of the periodic table in groups 6 and 7, or groups 16 and 17, in group 6, they have 6 outer shell electrons, so it's easy for them to gain 2 electrons, so they have a 2- charge, oxygen 2+, sulfur 2+, and then finally group 7 has 7 outer shell electrons, gains 1 electron, and then becomes 1-. That's fluorine minus, chlorine minus, and bromine minus. So now we're going to move on to ionic bonding. So an ionic bond is the electrostatic force of attraction between oppositely charged ions. So this means that it's the force of attraction between these 2 ions that hold them together to form a bond, and the reason that they're together is because they're oppositely charged. So groups 1 or 2, the group 1 or 2 atoms have 1 or 2 electrons in its outer shell, therefore they want to lose those electrons to become stable and have a full outer shell. And that's the opposite of group 6 or 7, which have 6 or 7 electrons in its outer shell, and they want to gain electrons, which gives the ion a full outer shell and makes it stable. And this results in 2 ions formed, and then they attract to each other electrostatically, and an ionic compound is formed. So if we put this into a diagrammatic scenario, it might make it easier to understand. So sodium and chlorine as examples. So here, sodium has 11 electrons, it has 2, and then 8, and then 1, and that's because it's in group 1, it has 1 outer shell electron. And chlorine in group 7 has 7 outer shell electrons. So if this electron joins on here onto the chlorine, then the sodium's going to have a full outer shell, and the chlorine's going to have a full outer shell. So sodium has lost an electron, more protons than electrons, so is positively charged. And then the chlorine has a full outer shell of electrons, and this red electron here is from the sodium, and so it has more electrons than protons, so it is negatively charged. So here, protons 11, electrons 10, so that must be positive. And here, protons 17 and electrons 18, so it must be negative. And this is denoted by Na plus Cl minus. Sodium chloride compound. So for the next exercise, I'd like to challenge you to draw and explain to me how you do magnesium and oxygen, how they would form ions, and then how they would form an ionic bond. I've put a periodic table here for you to deduce the charges from the groups in which they're in, and then we can speak through after. Perfect. So the targets completed today, we've recapped on electron shells, we've understood the rules, and we've really solidified that. We've understood how ions are formed from the periodic table. We know how ions form ionic bonds and how to draw this. And we can understand that ionic bonds result in the formation of an ionic compound. So if you have any questions, let me know. Thank you.